Hi students, welcome back to that is your channel Physics by Imagination. Dear students, in the previous class we had understood about that is moving charges and magnetism. So in this class we are going to understand that is sixth chapter, Electromagnetic Induction. So here, before understand about electromagnetic induction, let us go for introduction part, that is pi. So dear students, already we understood what is pi. So pi is nothing but the product of magnetic field and the area of surface. So if I consider a surface and it is a magnetic field and there is a normal vector n, and this is theta between normal vector and the magnetic field. So what is my point here? This pi becomes that is BA cos theta, where B is magnetic field, A means area of surface. Or we can tell in simple way, what is magnetic flux? The number of magnetic field lines passing across per unit area, that is called magnetic field flux, or we can call magnetic field lines of a flux. So now if theta is equal to 0, you know cos 0 is 1. So it becomes the magnetic flux is maximum when theta is equal to 0, and if you put theta is equal to 90 degree, that is pi is equal to minimum, because cos 90 is equal to 0, hence the magnetic flux is 0 when it is 90 degree perpendicular direction. So after understanding this, let us come to the point, that is our chapter name, Electromagnetic Induction. So what is electromagnetic induction? It was first explained by, that is Michael Faraday. Hence it is called Michael Faraday's experiment. Dear students, Hans Christian Ohms, he told that where is a current, there will be a magnetic field. Means whenever, suppose this is current carrying conductor, around this it is going to produce magnetic field. Simple way I can tell that Oersted told that where is a current, there will be a magnetic field. But Faraday thought reverse and got Nobel Prize. What he is telling, where is a magnetic field, there will be a electric current. So let us understand electromagnetic induction. So this is the construction part of Michael Faraday's experiment. It consists of a copper wire which is coated on the hollow tube, coated with what? Copper wire. And the two ends of the copper wires are connected to galvanometer, and this is a bar magnet. This is all about construction of Michael Faraday's experiment. Now if I take this magnet, if I push inside, so you know that galvanometer is going to find the small amount of electric current in the circuit. Now what is my point? When I push inside the magnet, then what happens here? There is the deflection in the galvanometer. The needle is oscillating. Why does the needle is oscillating? Because there is the interaction between this magnetic field and the coil. Dear students, when I push a magnet inside the coil, so this is, I am pushing inside the coil, there is the interaction between this magnet and there is a disturbance of the electrons in the wire. Electrons will start to move and constitute electric current, that is called electromotive force. So the first case is that when I push this magnet inside the coil, current is moved and deflection has shown left direction in the galvanometer. Current is moving in this direction. So that is called induced current. And this process is nothing but electromagnetic induction. It means electromagnetic induction. So when there is a relative motion between the magnetic field of the bar magnet and the coil, it is going to generate induced current, or we can call electromotive force. It means the process of producing electromotive force or induced current by changing the magnetic field, that is called electromagnetic induction. So when I push it, there is a deflection in the galvanometer. So second point, if I bring the magnet outside, again there is a shocking news. Again it has shown deflection but towards right direction. and current is moving in opposite direction, because the direction of the current which is moving along the direction of the magnetic field. Now what is my point here? Deflection is opposite side but current induced. This is second case. So third one, I kept coil here and it is rest. We can call a stationary point, or you can call simple word rest. This is rest. So can we find any kind of deflection in the galvanometer? No, because there is no interaction between the magnetic field and the current. Hence no deflection, no induced current. No deflection and no induced EMF. That is, we can call EMF. So next, fourth point, if I increase the speed of the magnet, what happened? There is a more deflection. So the induced EMF also depends upon speed of the magnet. So by concluding these things, so he told that even if I increase speed of the magnet, also can increase EMF or induced current. So by concluding these things, he had made two laws, that is called Faraday's laws, or Faraday's laws of electromagnetic induction. So let us understand very fast. This is crash course, so I am not going to write a statement, directly I will tell with a simple explanation. The first law is nothing but very simple. Whenever there is a change in magnetic flux, so this I am going to push inside, changing, linked with the coil. There is a relative motion between the coil and the magnet, induces an EMF in the coil. That is called first law. Means the electromotive force is equal to, that is, magnetic flux. If magnetic flux changes, that is, electromotive force will be increased. So I am repeating once again, whenever there is a change in magnetic flux linked with the coil and EMF induced in the coil, that is first law. Second law, how does this is going to be generate EMF? So he is telling that the magnitude of the EMF is directly proportional to rate of change of magnetic flux. The magnitude of the EMF means is directly proportional to rate of change of magnetic flux. In 1 second, how much magnetic flux is going to be changed? That is going to give the result of electromotive force. So this is two laws, simple. And here minus direction, because magnetic field and EMF are opposite to each other, change in magnetic flux. And by using this is first law and second law. He concluded some observations, very important point for examination. How could we increase EMF in the conductor? Dear students, very simple point. I have made very simple. That is yes. Okay, we can remember that very easily. MSN. So what is MSN? So MSN is nothing but what? This is M means magnetic field. So what is magnetic field? Dear students, M means magnetic field. So if I increase strength of the magnet, that is going to increase electromotive force. And S means, that is area of the coil. So that is surface area of the coil. If area of the coil increases, means it is going to generate more amount of EMF. So we understood, if I increase strength of the magnet, EMF increases. If I increase area of the coil, again it increases what ma? That is going to increase EMF. Next, speed of the magnet. If I increase the speed of the magnet, it is going to increase again EMF. Next, so we are again N means number of turns of the coil. So we can tell that it can be increased EMF by increasing number of turns of the coil, by increasing strength of the magnetic field, by increasing area of the coil, by increasing speed of the magnet. So this conclusions which has drawn by that is Michael Faraday, and he got Nobel Prize for this experiment. So nowadays it is using more in our day-to-day life. So next, after understanding this, what we can tell, that is Lenzis Law. Lenzis Law. So what is telling children? Very simple. Lenzis Law. So what is Lenzis Law means? Is telling that EMF is equal to minus d pi b by dt. This is very important, children. So it is also, we can written as del cross E is equal to minus dou b by dou t. So this is, you will study in higher studies, means this is the vector product of the del cross E is equal to minus dou b by dou t, and this is very important for CET and NEET. Remember, directly he may give the pi value, and he may give example pi is equal to 3t square plus t. He will ask you to find the EMF, very important. So now what is Lenzis Law means? The induced EMF or induced current is always such that which opposes that cause produced in it. Means the change in magnetic flux that is going to generate induced EMF. Okay, and it leads to law of conservation of energy. How? You know that law of conservation of energy. Energy neither be created nor be destroyed. We can convert from one form to another form. Okay, that is fine. Now what is my point here? How? I am going to move the magnet inside. That is mechanical energy. That will convert into electrical energy. So the total energy is conserved, and we can convert from one form to another form. Here we have converted, that is mechanical energy into electrical energy. So then it is going to come under law of conservation of energy. And one more important point, students. So if I produce less amount of magnetic field, it is going to induce sometimes more amount of electric field. So sometimes it is going to violate law of conservation of energy. So we discussed Lenzis Law. Next, come to the point, important point, that is motional EMF. What is that? Motional EMF. Dear students, in the name only it is there, motional EMF. So imagine this is P, Q or S. It is a conductor which kept in the uniform magnetic field. Which kept in the uniform magnetic field. So imagine this is the conductor I am keeping perpendicular to the magnetic field. Then what is going to happen? Then in this conductor we are going to change, and we are going to find there is a production of EMF. There is a production of induced current. So that is called motional EMF. Means I am going to move the conductor in the magnetic field. Here what did I do in Michael Faraday's experiment? I moved the magnetic field and coil was at rest position. So this is called motional EMF. The process of induced EMF in the conductor when it is kept in the perpendicular direction of the magnetic field, and when you are going to move, that is motional EMF, because the motion of the conductor in the magnetic field produces EMF, that is called motional EMF. Let us get expression for this. So this magnetic flux is equal to, that is BL into X. So we know that magnetic flux is nothing but product of B into area. So here length I have taken, that is L, and this is I have taken as X, length into breadth, area of this square. So now what I can tell that according to Faraday's law, that is EMF is equal to, that is minus, that is d pi b by dt, means the induced EMF is directly proportional to rate of change of magnetic flux. So it becomes E is equal to minus d, that is BLX divided by dt. So I am going to take constant term, this outside. What is going to become? This will take plus. Then E is equal to minus, that is L into B dx by dt. So dx by dt, according to calculus, we can tell that this is nothing but velocity, that is we can write BLV. This is called equation 1. This is what ma EMF in this motional EMF. Okay, now we know that according to Lorentz force, F is equal to, that is QEB. This is in the magnetic field. Okay, so then what happens, children? This is force. Now again we know that EMF is nothing but what? Okay, and here amount of potential difference, we are bringing the charges from here to here, PS. So amount of work done is given by, that is W is equal to move the charges from P to S. Okay, we are moving from here to here. Then we can written as work is equal to force into distance. General formula, work is equal to force into distance. Now force, we can find that what is force. So this is QUB is there, that is QVB, and distance is L. So this becomes, students, QVBL. This is called equation 2. Now again come back to the point, that is according to, that is what we can tell, EMF is equal to, that is work done by charge. What is work done? That is work done is, what is here? That is QVBL divided by Q cancel. So E is equal to BVL. So here what is B? Magnetic field. V means velocity of the conductor, L means length of the conductor. So this induced motional EMF depends upon these factors. And very important point, last but not least, the unit of magnetic flux, B magnetic field is Tesla, and this is Tm square, Tesla meter square, and this Tesla meter square is nothing but 1 Weber. And remaining topics we discuss in the next class. Dear students, I hope you understood. If you understand, please like it and share and subscribe. Thank you.